Hello, hello, hello. We are here with another T3D session from More Than a Refresh. These are 10 minutes to educate us as quickly and as in-depth as possible. Our guest today is Aaron Cutshall. Aaron, introduce yourself.
Yes, so my name is Aaron Cutshall. I've been working with database technology since the 80s, and it has evolved and grown over the years. And I hope to be able to provide some insights to how we can still help improve.
What are we going to be talking about today?
The thought that occurred to me was about set-based processing. It's something that unfortunately is not being taught in schools so much anymore. Back when I was in college in the 80s, I actually took a database theory class where we learned probably a lot more than what was really necessary to be able to use the database, such as, what tuples really are and things of that nature. But it provided a lot of foundational knowledge for me. And I noticed that in most school curriculums, they're teaching classes that are focused on the languages that are more popular today, such as Python or JavaScript or something of that nature. And those are procedural languages. And even though Python does a great job of being able to connect to a database and allow you to utilize the data in there and to actually perform queries, the data that is returned still tends to be processed in a row by row fashion. Or as my friend Jeff Moden would say, a row by agonizing row. And so
Well,
therefore,
it iterates, right? It doesn't pull it all in as one set and process it.
that is correct. And so, if someone who's knowledgeable enough, they can write the query to perform that in a set-based manner, the results get still processed row by agonizing row.
Well, isn't that, we're of different generations, but it's still, that's where the whole old man argument of do it in the database comes from.
Yes.
Right. So that you're processing row by row the result, not the data to make the result.
Correct. Because otherwise, people treat the database as nothing more than a repository of the data itself. I have seen environments where all of they say the business logic is in the code layer, and all of that code is written in procedural code language, whether it's C# or Java or Python or whatever it may be. And the database is treated as a file system, and tables are treated as files. And so they will bring in, oh, here's my customer data, and bring that in. Here's my products data, let me bring that in, and then let me sort through the two so I can see which ones correlate. And it becomes a very procedural process. They will even go so far as, yeah.
So I'm hearing two problems here. One, I'm hearing, and this has been a problem for decades, is that academia doesn't teach foundational knowledge anymore.
True.
And foundational knowledge would be, what is a tuple? What is the heap? What are sectors on a hard drive? Those types of things. And I even read an article a while back of a physics professor that the first week or 2 weeks of his course was actually teaching foundational knowledge of using a computer, because the students didn't understand the idea of directories and files. They understood the idea of meta information that they search for and gets displayed to them by Google or whatever else.
Right.
So that's problem number one. But problem number two is really an ignoring, and maybe you're going in a different direction in this, but based on using the iterative approach and treating the database like a file system, you're actually losing all of performance that can be provided to you by the database.
Exactly.
And instead, you're scaling out this way in an exorbitant way now because it's in the cloud, so it's very expensive in comparison to scaling up this way.
That's correct. and you're not allowing the database to do what it's designed to do. Relational databases are designed to take this data and bring it together and produce it in a set-based manner for you to consume.
So
And
talk
when
to us
you're
about what that is. What is a set-based man? Because we already established that a lot of people don't have the foundational knowledge.
okay.
So what is the set-based?
Okay, sure. Good question. So let's say, for example, if I need to perform an analysis on a data set, on a table, for example, or just make it simple, one table, and I want to instead of going to row by row and checking, does this data have what I need? Yes, no, set it over here. Does this next row have what I need, et cetera, and looping through those records, I can then say, give me every record that matches this criteria. That is a set-based operation. Now, when I go to do more complicated operations, such as an update, or if I join two multiple tables together, then the database engine is designed to be able to look at those relationships and be able to work with the data as a whole. It's like saying, I want a basket of apples instead of taking one apple at a time out of the basket.
So in a not necessarily layman's terms, but it's a batch retrieve versus a
Yes,
batch import.
correct. In fact, the one of the examples I used before is that you've got ball bearings. Some are steel, some are copper, some are plastic, and they got spilled all over the floor. Now, if you want to collect those and sort them back into the three different buckets, what would you do? And a procedural process is to pick one of those up, determine is this plastic, copper, or steel, and put it in the appropriate bucket and go to the next one. That's an iterative approach. Whereas a set-based approach would be, say, let me get the steel ones first, so then I'll take a magnet and pick them all up. And then I've got all the steel ones. And then I take the rest of it and put water in it. And then the plastic ones float, so I can scoop off all of the plastic ones. And what's left are the copper ones.
I have a
That's a
metaphor for
set-based
you on that.
approach.
I have a metaphor for you that you might want to consider. It's the coin machines. You go to the store and you just dump your big plat of coins, and it just
Exactly. Yep.
it just knows how to deal with them.
Yep. That's a good analogy. That's a set-based insert mechanism.
Right. So the set based on this, the real advantage is performance more than anything, I would think.
Exactly.
Right. Because just like a batch import, a batch retrieve is going to perform better as a whole than any iterative approach.
Correct. And it doesn't matter how many servers you scale out to do singleton operations, you're still limited by how you're doing that as a singleton operation. Yes, you can improve performance by adding more servers, but you're still doing that iterative process. Whereas database engines are designed to do things as a set. So why not leverage that?
Well, I think for a lot of people, they don't understand it.
Mm-hmm.
Again, because they don't have that foundational knowledge. It makes more sense, and I can see this, right? As someone who I do not have your traditional academic background, I learned all this in the war, right? And it makes sense that I would pull all my data in to my iterative stack to go through it. Right. That thought process makes sense if you don't have the foundational knowledge.
Right. And that is the process that we used to use way back in the 70s and early 80s when we were doing file processing. We get one row at a time, process it, and go to the next one in an iterative fashion.
What do you think? I mean, I've actually run numbers on this before. What do you think the performance metric difference, right, is between, let's say, 5,000 rows being pulled into an iterative process versus just a batch retrieve, a set retrieve?
Of course, there is a lot of variability in that.
Yeah.
But I would say you're going to get more than I'd say 5 times your performance.
Easy.
Easy.
And this is why. If you don't believe Aaron, just do this. Invert the process. Do a line-by-line import, and then do an import with 10, and then do an import with 1,000, and then an import with 5,000, and time them all.
Yep.
And you will find it does depend on the size of your buffers and what kind of disk you're using and stuff like that. But a 5,000 row import is going to be exponentially faster than a line-by-line.
Definitely.
And when you do a non-set return and you're iterating over your results in your stack, you are paying that same price. It just gets masked by the middleware.
Right. And so there's a caveat there too, because database engines are, like Postgres, are designed for set-based processing. That means that they're not going to be optimized for iterative processing.
Right.
And some operations, such as string processing or other things that are very heavily procedural, aren't as effective to do in a relational database. And so then you would want to use a procedural process for those things. That's why Python is great for string processing and string matching, searching, etc. It's really great at that, but it can't do things in a set like Postgres can.
All right, sir. You had 10 minutes. What's your closing thoughts?
I would say that your example of an experiment is a very valid one. And there are other ways that you can do that, but expand your processing, your mindset to be able to process data as a set and to be able to think of it as a whole instead of as a bunch of records that you have to process one at a time. Think of it as something you do all at the same time. And that will make things a lot easier for you.
You're asking people to think of the bigger picture, sir.
Exactly.
We wouldn't be in the societal situations that we are if they could think of the bigger picture. And with that is the last, not the last, but that is this episode of T3D session. Thank you, Aaron, for joining us.
Thank you.
And I look forward to having you on again.
Thank you. Appreciate it.